When we navigate around the forum, now that we fetch all our data asynchronously, we see that the data appears in random order, causing the forum to look weird. I'm thinking that it would be nice to have everything in place before we display the contents of the page to the user. In the meantime, while we are waiting for the data, we should display a loading indicator or a progress bar. This requires quite a bit of work, so let's do it in baby steps. The first step will be to hide the component's template until its data is fetched. To do that, we'll use a data property in each component, like ready, that will switch between true and false. Based on that value, we'll hide or show the component's contents. I will start with the home page. I will add the ready data and set it to false. Then, I will wrap our content in a single root element and apply a VIF to it. Now we have to set ready to true when all the data is fetched. In the components created hook, we fetch all the categories and their forums. We do that by dispatching the fetch all categories action and the fetch forums action. Let's add an await to fetch forums so that we know when it's finished. Then, after we know everything is loaded in, we can set ready to true. Awesome. This time, the categories and the forums are displayed together at one time. We want to implement this functionality on all our pages, but it would be a maintenance nightmare if we hard coded this ready state into each page from scratch. In the next lesson, we'll scale our solution and implement it on all the pages. As we hid the template for the home page component until its data is fetched, we want to hide the template for all pages. We can, of course, repeat what we did in the previous lesson for all page components, but that's not ideal. We have a couple of options for making this functionality available in multiple components. One option is to use Vuex. Store the ready data and update it using actions and mutations. Another option is to create a base page component and extend it. Also, this is a common use case for mixins. All of these options are fine. For the sake of this example, we will use mixins. Mixins are a flexible way to distribute reusable functionalities in Vue components. A mixin is an object that contains any component options, like data or methods. When a component uses a mixin, all options in the mixin will be mixed into the component's own options. Let me show you. First, I will create a mixins directory inside the source folder. Here, we will create our mixin, which we will name something like page component mixin, or maybe async data status. From the mixin, we want to export an object with the options. To begin with, we can add the data option that will include the ready property. To use our mixin in the home page, we have to import it and specify it in the component's mixins option, which is an array. Now we can remove the data from the component, and hopefully, back in the browser, the home page will work as it did before. And it did. In the home page component, we set ready to true directly when all the data is fetched, though it is more elegant to create a method in the mixin to do that, since in the future we might want to do more things when the data is fetched. For instance, we might need to emit an event. Thus, I will create a method that I'd like to name fetched. It's recommended to prefix all properties of a mixin to avoid conflicts with the component's properties. For example, ready is a property name that you or any other developer might use on a component that uses our mixin. I will use the mixin name as the prefix, and I will separate it using an underscore so that the ready property will now be async data status ready. We will do the same for the fetched method. In here, we just want to set ready to true. Let's get back to our component and use our new properties. When the data is ready, we'll call the fetched method. We also have to update the ready property on our VIF. This convention might feel a bit frustrating, but we not only guarantee that the mixin's properties won't produce conflicts, but also it's straightforward to find where the option is defined. If we were using, for example, 5 mixins in this component, we would have to guess or go over all mixins to find where the ready property is declared. Okay, with the mixin in place, we can go through the page components that get data asynchronously and hide their contents until the data is fetched. These pages are the category page, the forum page, the thread create, edit, and show page. For the user related page, we will come back soon when we implement authentication. To get started, I will import the mixin into these components. Then, I will define the mixins property. Next, we have to add the VIF on the root elements to hide their contents until the data is ready. In many components, we were hiding the template until a property, like the forum, was fetched. We don't need that anymore since the ready property guarantees that we have all the data. Lastly, we have to call the fetched method coming from the mixin when all the calls are done. We'll make sure we have awaited all action calls and then call fetched. Okay, looks good. Let's browse our forum to ensure that we didn't break anything. Awesome. This time, all the contents show up together. In the next lesson, we will conditionally display the page components to show a loading indicator while the data is being fetched. In the previous lesson, we hid the page components templates until their data is fetched. As a result, we see a blank page while we are waiting for the data. We can go a step further now and display a loading indicator until we eventually display the components template. If we were to do that in each component separately, we'd conditionally display the contents or the loading based on the value of ready. This works fine, but we don't want to repeat this functionality in every component. And when at some point down the road we want to update the loading message, we don't want to update it in every component. Though, if you are building a small application with only a couple of pages where the markup hierarchy is flexible, this approach is fine. There are a couple of elegant ways to share this functionality between all the page components. The one I like the best is to conditionally display the router view element. In case you didn't know it, the router view component coming from view router renders the match component for any given path. In other words, this component is the one that renders all of our page components based on the URL. Thus, in app.view, we can conditionally display the router view or the loading. I will remove the logic from the home page and replicate it there. Let's say we have a show page property that we will base our statement on. I will add the show page property and set it to false by default. Next, we have to set show page to true when the active page component has fetched the data. To notify app.view from the page component when the data is fetched, we will emit a custom event. We can set up an event listener on router view for the event, let's say ready. When the data is fetched, we set the show page variable to true. Next, we have to emit this event from the page components. All these components call the fetched method from our mixin when they are done. So, here is the right place to emit the ready event. Let's review what we have done. In the page components, like home, we call the fetched method of the mixin when the asynchronous calls are done. In this method, we emit the ready event. And in app.view, we listen for this event, and when it happens, we set show page to true, and we hopefully display the contents of the component. If we check it in the browser, it looks like we're stuck loading. This happens because we are rendering router view using vif, which means that the component is not rendered unless show page is true. So, if we check View DevTools, only the app and the navbar components are being rendered. In order to set show page to true and eventually display the page, we need to render the component first so that it fetches the data and emits the event. To solve that, we will conditionally display the element using vShow instead of vIf. The difference between vIf and vShow is that vIf will render the element when the statement is true, and otherwise it will remove it from the DOM. On the other hand, vShow will always render the element and keep it in the DOM, and conditionally update the CSS display property to either show or hide the element. In general, vIf has higher toggle costs, while vShow has higher initial render costs. Thus, prefer vShow if you need to toggle something very often, and prefer vIf when the condition is unlikely to change at runtime. Because vShow doesn't support vElse, I will add a vShow to the loading div and show it when showPage is false. Here, we could also use vIf and render the loading conditionally, though because we will toggle the visibility of the loading every time we navigate to a page, it's cheaper to render the element once and hide it conditionally using vShow. Back in the browser, we now see the loading message and then the contents of the page. Though, if we navigate to another page, we still see it empty until the data is fetched. This happens because we set show page to true the first time a component is ready, but we never reset it to false. Because the Firestore calls are fast, we don't really get the time to realize what's going on. To help us, I will delay all the calls by setting a timeout before resolving the promise in fetch item, which is the base action that all fetches rely on. Now, in the browser, we have some time to grasp the flow. So, you see that show page is false in the beginning on a fresh reload. Then it becomes true and never changes back. The time when we want to reset it is right before we navigate to another page. To run code before navigating to another page, we can take advantage of view routers before each method. Inside app.view, in the created hook, we can access the router under this.router. So here we can call before each and pass in a callback. Inside the callback, we want to set show page to false. If we check back in the browser, our loading works like a charm, though the page components that do not fetch asynchronous data, like the not found page, will never show up. This happens because they do not emit the ready event, and show page never becomes true. Let's fix that. Here, we can use our mixin, but we can also just emit the event in a component's lifecycle hook, like the created. In the next lesson, we will get rid of the boring loading text and replace it with a cool loading spinner. In the previous lesson, we added a loading message. it's time to replace it with a cool spinner. There are dozens of libraries to set you up with spinners. For our case, I have picked SpinKit. SpinKit is a library that offers many spinners that you can install through NPM or by just grabbing the spinner you like from their website. I will do that since we don't really need to install a library to use just one spinner. I will create a component for our spinner. This is a base component, and thus I will name it App Spinner to be multi-worded and comply with the style guide. In the template, I'll place the markup we got from SpinKit, and next, copy the CSS in the style tag. I'll also make it scoped since the styles only apply to this component. Here, we can easily change the color of the spinner, so I will change it to the forum blue. Let's use it now in app.view. Since the component name starts with app, it's considered a global component and is already registered for us in the main.js file, so we can just go ahead and use it in the template. Back in the browser, we now see our spinner while we wait for the data. In the next lesson, we will implement the progress bar. Even though our spinner is just fine, we can make our application even fancier by displaying a slim progress bar right before the nav bar. In Progress is a great library that provides exactly that. It's also straightforward to use, requiring a call to a .start method to start the progress bar and a call to end to stop it. Let's get to it. I will install it using npm. Now we can import it in app.view. We also have to import its CSS inside the style tag. Here, we can use the tilde shorthand to point to the node modules directory, and then navigate to In Progress CSS. Good. We want to start the timer every time we are about to visit a page, thus in the before each router method. Next, we want the progress to complete when the page component is ready. We have an event listener for that, so I will create a method, something like onPageReady, and move the previous code here. When the page is ready, we should also complete the progress bar. Thus, here we will call inProgress.done. Let's check it out in the browser. It works great. Cool. Though it feels a bit slow, and the spinner on the right is a little bit excessive. We can configure these before we start the timer using the configure method. I will set the speed to 200 milliseconds. and hide the spinner using the Show Spinner option. Next up, I don't really like the color of the bar. There is no option to change that, but we can target the element using the hashtag progress.bar and set the background to the color that we'd like. Okay, let's give it another go. Great, it feels a little nicer this time. Now that we've got the loaders in place, let's remove the timeout from the fetch item action we added earlier. And it's fast again. I can barely see the spinner, but it's still there and will be especially important for slow connections. The Firebase CLI provides a variety of tools for managing, viewing, and deploying to Firebase projects. In other words, using the CLI, we can manage our cloud functions, interact with the Firestore database, deploy a project to Firebase, and so much more. For now, I want to use the Firebase tools to delete all the Firestore collections without having to manually do it from the browser. While the Firestore export import library we installed earlier is great for importing our data, we can't keep running it to get fresh data. Instead, it just adds to the data that already exists. In order to seed the database in the next lesson, we want to be able to delete the data first and then import it. To use the Firebase CLI, we have to install it globally. In order to install it, you need to have Node and npm installed. We could install the package with yarn by typing yarn global add Firebase tools, but I prefer npm. So I'll run npm install -g Firebase tools. Once it has installed, we have access to the Firebase command in the terminal. Now you have to log in with your Firebase account by running Firebase login. Here, we are asked if we want to help out the Firebase team by sharing information anonymously about the CLI usage and error reports. You choose whichever you'd like, yes or no. The next step is to visit this magic link in the browser in order to log in. Very nice. After logging in, we have to associate our application with the Firebase project. To do that, we will run Firebase init. We are asked here which CLI features we want to use. You can select features by navigating up and down with the arrow keys and using the spacebar to select an option and hitting enter to confirm your choices. I will pick only the Firestore for now. We can easily add new features later by running Firebase init again. Next, we have to pick the project we want to associate with our application. We'll use an existing project. that is, the View School Forum project. I will stick with the default file name here. And here. Alright, we're done. The CLI has created 4 files for us. The Firebase RC file, which is the configuration and includes the name of the Firebase project. The Firebase.json file, that includes the configuration for the application, like the name of the file where the database rules are set. The Firestore indexes file, where you can define custom indexes, and the Firestore rules file, which is the same as the rules we have specified in the Firebase console. We can update the database rules by changing the Firestore rules file and running Firebase deploy. If we check back in the browser, the time at which the read write access expires has changed. Cool. It's worth noting here that this setting is why we've been able to so easily make updates to posts and threads so far. We are allowing read write access to anybody as long as the date is before July 21st, 2021, which at the time of this recording it is. This is so that development can remain simple, but as we progress, the rules will obviously have to become stricter and based on the user's identity. In the next lesson, we will seed our database using a combination of the Firestore export import library plus the Firebase tools. Every time we try out some new features in the forum, we kind of pollute our database. Also, during development, it's very likely to store invalid data. Having to go into the Firebase console and manually delete all the collections, and then rerun the Firestore import script like we did back in the incrementing the user's post count lesson will quickly become tiresome. To help ourselves, we can use the Firebase CLI to delete the collections in the Firestore before re-importing them via the Firestore import script. The Firebase CLI provides a command called firestore delete. We could delete the collections one at a time by providing the collection name and the recursive flag. The recursive flag instructs Firebase to delete all documents in the posts collection, as well as any documents that might be nested inside of a post document. This would get tedious though, as we'd have to call it for each collection. Let's run the firestore delete command with the --help flag to see if there's a better way. Oh, nice. In order to tell the Firebase CLI to delete all the collections, we can instead just provide the all collections flag without specifying a collection. Now we're prompted to confirm the deletion. Press Y for yes and hit enter. Awesome. If we take a look at the Firebase console in the browser, you can see that all of our collections are gone. This gets us halfway there. Now let's run the Firestore import script. Great, now the data is back, and we can be assured that it doesn't have any of the test data in it. It now looks exactly like the data in the data.json file. This works okay, but having to run two commands to reset our database and then reseed it with all the initial data is annoying and is ripe for confusion. Let's create a custom npm script to do both of them at once. We can define custom npm scripts in the package.json file under the scripts key. We'll give it the name db:/seed. And then we'll run both commands separated by double ampersands to run one right after the other. The double ampersands mean exactly what you probably suspect they mean. Run one command and then another. Also, in order to keep the Firebase CLI from prompting us to confirm the deletion of all the collections, I noticed in the help printout that we can add a yes flag to the firestore delete command. Finally, before we run it, I want to create a new post in the forum just to demonstrate that once we run the db:/seed command, that our database will be back to its initial state. Cool. When we search for it now in the Firestore database, we see that it exists. Now, let's run the seed command and watch it disappear. Now, in the Firebase console, the post no longer shows up. And it doesn't exist in the forum anymore either. Seeding is a great way to get fast and predictable data when developing an application. Reseeding your development database from scratch along the way will also help eliminate invalid data produced by code that is a work in progress and make the development data more predictable across time and team members. In the next lesson, we'll dive into environment variables. Environment variables are variables that can have different values depending on the environment in which your application is running. This can be useful for a number of different things, such as connecting a staging application to a different database than your production application, using different API keys between environments, or allowing different developers working on the same project to use their own third party service accounts for different types of testing. In our case, we don't necessarily need to support two different environments at this time. We're still a good ways off from working anywhere other than our local development environment. Nonetheless, this will be a good opportunity to showcase the power of environment variables to improve our workflow. The Vue CLI supports environment variables out of the box, so all we have to do is start using them. But where do we start? We can start by defining a .env file in the root folder of our project. The .env file can contain any number of key value pairs. The keys are defined first. It's common practice to uppercase these. Then, the keys are followed by an equal sign, after which we assign the value. And that's all there is to defining an environment variable. But where does the support for different environments come in? Well, besides creating a .env file, you can also create any of the following: .env.development, .env.production, and .env.test. There's even more .env file name possibilities than just these, but we'll look at that a little bit later. The production, development, and test keywords correspond to the mode in which your application is bundled. For instance, when you run npm run build to build your application for production, the mode will be automatically set to production. On the other hand, when you run npm run serve to spin up a development server, your mode will be automatically set to development. Finally, test mode is used during unit testing. So, this means that if you want an environment variable to be one value in development, you'd assign it in the .env.development file. And if you wanted it to be another value in production, you'd assign it in the .env.production file. If you'd like for it to be the same in both places, you can define it in the regular old .env and remove it completely from the other two. There's also a hierarchy for these files. So, if for instance you define my variable in the plain.env, as we've done here, but then you also define it in the .env.development file, when you're running in development mode, the environment variable from the .env.development file will override the same environment variable in the .env. This works the same for .production and .test as well. So, how can we use this in the forum application? Let's move the Firestore connection details to a .env file so that later on it'll be possible to have one Firestore database for development with our dummy data from data.json and a completely different one for production that can store the real data. In the .env file, let's create environment variables for each of the Firebase configuration variables defined in config/firebase.js. I've prefixed each env variable with view_app so that Vue knows these env variables are safe to expose in the client bundle. We'll talk about this a little bit more in the next lesson. Now, we can access those variables in the Firebase config file. Environment variables are accessible on the process.env object. For Vue CLI to pick up on changes to the .env files, we need to restart the server. We can do that in the terminal by pressing Ctrl+C to kill the process. Then we can rerun the serve command. If we visit things in the browser, we'll see everything is still working. In this lesson, we saw how environment variables are useful for configuring our application differently depending on the environment. In the next lesson, we'll take a look at another advantage of environment variables, that is, hiding secret information from your source code in version control and from the client side. In the last lesson, we saw how environment variables are a convenient way of configuring our application based on the environment in which it's running. In this lesson, we'll see how we can keep our code more secure by hiding secret information in environment files. Besides the .env and its alternative forms appended with production, development, and test, there is another keyword we can append to .env files to keep them from being committed to version control. This keyword is local. You'll notice in VS Code, the file name is grayed out just a bit. This is to indicate that the file is not being tracked by Git. That's because in our .gitignore file created by Vue CLI, this file is being ignored. You'll also notice here that you can append .local to any of the .env files with the mode. That means you can create local env files such as .env.development.local or .env.production.local. If you're used to having a .env in other projects like Laravel that are ignored in the repo, the .env.local is really Vue's version of it. So, why is this necessary? Two reasons, really. First, because it's usually a bad idea to store secret or sensitive information in your Git repositories. For instance, if you're part of a team, you might want to use your own test account for a third party service like Stripe or PayPal. I'm sure you can imagine the horrible consequences that could come from sharing the production credentials of your Stripe or PayPal account with a person with bad intentions. That's why the .env.local file is so valuable. Secondly, this is another way in which environments can be differentiated. Now, it's not a difference between production and staging, but a difference between my machine and anybody else's. Variables you define in the local env files will always override any of the variables from the other .env files. That means if I wanted to use my own Firestore instance besides the one shared in the .env file that's committed to the repo and shared with the rest of the team, I could override them here in env.local. And no one else would ever see them because this file doesn't get committed to version control. While this could be helpful to keep me from tripping over data inserted by another developer working on the same project at the same time, it's worth noting here that the Firebase variables aren't really secret because they are exposed in the browser. With Firestore, the real security comes from the rules defined in the console. That's why we could define the Firebase environment variables with the Vue app appended to the front. In fact, we had to define them with Vue app appended to the front. Otherwise, the build would not inject the variables into the bundled client-side code. This is a safety measure provided by Vue CLI to keep you from accidentally exposing secret information to the client. I'll just remove this .env.local now, as I won't be needing it. Honestly, you won't find yourself using secrets in env files very often in projects created as Vue SPAs, since most of it gets bundled for the client anyways. The only piece that isn't client-side is the build step, but there are certainly use cases where you might need to provide some sensitive data for your build to complete. More often than not, however, the local env files are best used for another layer of environment differentiation, that is, my machine versus yours. So, there you have it. With environment variables, you'll be all set to run your application in different environments, customize your local environment for personalized development, and keep secrets secret. Now that we have improved our workflow and all data is stored in the database, it's time to move on and implement user authentication. Before we start working with the Firebase API, we will work on storing users in our database. To begin with, I will create a registration form. I will get the markup from the mockup seen here. I will copy the form and put it into a new register.view page component. Next up, I will create some data to store the values of the inputs. I've found that wrapping the form's data in a form object works really well for me, especially when the initial values are coming down to the component using props. The form object will have a name, username, email, password, and avatar properties. Let's bind these properties to our inputs. When the form is submitted, we will call a method. Let's say register. I will create this method, and for now, I will just send the data to the console, since we don't have an action to store the user in the database yet. That's enough for the page register component. Now, we have to emit the ready event so that the page gets rendered. Cool. Let's create a route and check it out. Now, if we visit the /register page, we see our form. And if we type some values and hit submit, we see the form object in the console. Great. In the next lesson, we will implement an action and store the user in the database. It's time to create an action and store new users in the Cloud Firestore. Before we do that, let's review what the user object looks like. Each user has an avatar, a bio, an email, a last visited at timestamp, a name, posts count, if they've had any posts, registered at, a threads array, username, and then the lowercase version of their username. The reason for storing the username also in lowercase is because in the Firestore, it's a good practice to store key properties in lowercase since queries are case sensitive. So, from all of these properties, when we create a user, we can fill in the avatar, email, name, registered at, username, and username lower. Let's create our create user action. In the payload, we should expect to receive the email, the name, the username, and the avatar. Let's make the avatar property optional by setting it to null if not passed. Also, notice we're not getting the password here. We don't want to store a raw password in the Firestore, but rather we'll set that in the next lesson directly with the Firebase authentication. Let's also make the action async, since the call to the Firestore will be asynchronous. Inside the action, we can start by setting the current time to the registered at variable. Next, let's do the username lower variable. Because in Firestore, it's good practice to store the properties in lowercase to make querying by them easier. We will convert the email to lowercase before storing it. We could have done the same for the username, but it's nice to keep this as a separate property in order to keep the original for display. Next, we can group together all the user properties in an object and send it to the Firestore. For now, we will create a new user ref with an auto-assigned ID. But in the next lessons, we will use the Firebase UID coming from Firebase authentication. Next, we'll use the set method to set all the user's properties. Now, we'll get a fresh copy of the user from the Firestore, as we've done with posts and threads. And then commit set item to store it in Vuex. Lastly, we'll return new user passed into doc to resource in case the code calling the action wants to directly access the new user. Cool. Let's dispatch our action from the register page. I'll also change the register method to async so that we can wait for the create user action to complete, and then redirect the user to the home page. Let's give it a shot in the browser. When I submit the form, I'm redirected to the home page, which means that everything worked. We can confirm that by checking Firestore in the Firebase console. Nice. In the next lesson, we will integrate Firebase authentication. Now it's time for the exciting part, integrating our registration form with Firebase authentication. This way, we will create a Firebase user while at the same time storing the user object in the Firestore. While I'll walk you through setting up Firebase authentication, if you'd like a more in-depth guide to using this service, we have a course on View School that you can check out before watching these lessons. It's linked in the description below. Okay, the first thing to do is to enable the email password provider in the Firebase console. You can do this by going to the Authentication tab and then clicking on Sign In Method. Now, we can register users in Firebase using a Create User with Email and Password function coming from the Firebase Authentication module. Remember that the Firebase Authentication service supports only specific user information. This means that we cannot store custom data, like threads or post count, to the user. What we can do instead is to register the users with Firebase and then store them in Firestore as we do now. For that, we have a couple of different options. The first option is to call the Create User with Email and Password function before dispatching the Create User action right inside of the Register page. And we'll have to import Firebase. Then, we will call our action and pass it the unique ID of the created user. The ID of the user in Firebase Authentication is called the UID. Let's update the Create User action to use the past ID instead of creating an auto-generated one. Great, let's try it out in the browser. Now, in the Authentication tab of the Firebase console, we should see this new user. And if we look in our Firestore database, we can see that it's stored there as well. That's nice, though I don't really like coupling our components to Firebase. This coupling should be done inside the store. So, if you ever decide to switch to another authentication service, you only have to update the store and not all of the related components. So, one option here would be to extend the create user action and call the create user with email and password function before storing the user to the database. The drawback of this approach is that the create user action would then be limited to only creating users with email and password in Firebase. So, if we want to reuse it when we register users with third party providers, we would need to repeat this logic. What I will do instead is to create an action that will handle the logic that we have now in the register method. I will name this action register user with email and password. Now let's set the arguments and also use them to register and store the user. Back in the register page, we can call our new action, pass it the form data, and redirect to the home page when everything is done. We can also remove this import statement as our component doesn't rely on Firebase library anymore. Let's check it out in the browser. We can create a user, and we see that the user is stored as a Firebase user, and it also exists in the Firestore. In the next lesson, we will sign users in to our application after they have registered. When we register a user through Firebase, we know that we can access the user in the session, though our application is not aware that we are logged in because we are not updating the auth ID in the state. Thus, in the navbar, we don't see the logged in user. To sign the user in right after creating an account, we could update the auth ID here. This solution will work, but it will be temporary since this would run only when the account is created, and thus we lose the authenticated user right after refreshing the page. How can we make this a little more solid? Remember that our auth user getter requires that the user with the specified ID exist in the state, so we have to make sure that the user is fetched before updating the auth ID. Let's update the fetch auth user action to get the currently logged in user from Firebase. We can grab the user ID from the firebase.auth.currentUser object. With the ID in hand, we can now fetch the authenticated user from the Firestore, and then update the auth ID in the state. I'll also use optional chaining on the current user.uid. So that way, if there is not a current user, we can just return early. Finally, for this to work, we'll need to create the setAuthID mutation. And at this point, we can get rid of that hard-coded authID in the state. To test drive our new action, we can call it after registering a user. I will create a new account, and then once I hit register, we should see the new user in the navbar. If I create a thread now, it will be assigned to the authenticated user. Though, as we expect, if I refresh the page, I am not authenticated anymore, since we are not utilizing the session Firebase has set for us. To fix that, we will use the recommended approach to get the authenticated user from Firebase, which is to use the on-auth state changed observer. First, I'll remove the action dispatch in the register user with email and password action. Now, we can use the on-auth state changed observer in main.js. So, when the auth state changes, if there is a signed in user, we will fetch them. In order to access the store here, we're using the store variable from where we've imported it previously. This is necessary in order to have access to the store outside of the View application instance. This should do the trick. Let's check back in the browser. This time, we are logged in, despite if we refresh the page or open the app in a new tab. This is great. At this point, the only way to sign in is by creating a new account, and there is no way to sign out again. In the next lesson, we will work on signing users in and out. In the last lesson, we logged the user in after registering them, but already registered users don't have a way to log in yet. Let's fix that. I will create a sign in page component. And I will copy and paste the markup from the mockup. Next, I will add a form object to the data. And inside an email and a password property. Let's bind these data properties to the form inputs. When the form is submitted, we will call the sign in method. Also, here I see that we have a link to create an account. Let's replace that with a router link. In the sign in method, we will dispatch an action to sign in. I will name this action sign in with email and password. When the sign in succeeds, we will redirect the user to the home page. Here, let's also display an intrusive alert if something goes wrong. Finally, in order for our page to work, we have to emit the ready event. Let's implement the sign in with email and password action. Here, we will call the sign in with email and password Firebase function and return the promise that it returns. Because we have set up the auth observer, our application will automatically be aware that a user has signed in, so we don't have to worry about updating the state manually. Let's add a route for the sign in page. The sign out functionality is very simple. Let's create an action for that. Here, we will call the sign out Firebase function, and then we can set the auth ID to null. Even though we have the state observer, we'll commit the set auth ID mutation in here because it's not a good practice to commit mutations outside of actions. And also, there won't be a way for users to sign out rather than dispatching the sign out action. If you prefer to do these in the state observer, you can create an action and dispatch it when the user is null. Okay, now in order to sign out, I will add a link in the navbar that we will render if there is a signed in user. When the link is clicked, we will dispatch the sign out action. When a user is not signed in, we'll show links for registering or for logging in. Alright, now we should be able to try out the whole flow. Since we're already logged in, first we'll use the sign out link to sign out. When we do, you see the logged in user's name and avatar disappear. Nice. Now we can log in again. Alright, now I'm signed in again, and you can see my user in the navbar. In the next lesson, we will work on the navbar dropdown to clean up the display of the sign in, sign out, and register links, and to learn about class bindings. In the previous lesson, we added some links in the navbar to control the authentication. If you take a look at the navbar component, you will see that we already have a link for signing out inside of the user dropdown. I will move our working link here and remove the condition, as the condition is already used further up in the DOM. And I'll change the class to the proper one for a drop-down menu item. According to this comment, to open the drop-down menu, we have to append this class. Let's do that to see how it looks. Okay, that's nice. To make this work dynamically, we can toggle this class when the user clicks on the dropdown. To implement that, we will use class binding. Class binding is a really handy feature of Vue.js. According to the guide, to dynamically toggle classes in Vue.js, we have two options. The first one is using the object syntax. In this example, the div will have the class active when the isActiveData is true. If isActive switches to false, the active class will be removed. So the class bindings are reactive. We can have multiple classes toggled dynamically by adding more fields to the object. So, in this example, the text danger class will also be added or removed conditionally. Notice the quotes here, where the class name contains a dash. Another way to dynamically toggle classes is using the array syntax. Here we have two data properties that are the names of the CSS classes. So, using an array in the class attribute, we can assign both classes to the element. This is very handy when you have the class names inside of your data. You can also toggle a class in the list conditionally using the ternary operator. On top of that, you have the possibility to use the object syntax inside of the array syntax. Let's get back to our code. First, I will add a data property. User dropdown open, so we know when the dropdown is actually open, and I'll default it to false. Now, in the dropdown element, we can bind the class attribute to an object, so we add the active drop class when the user dropdown open data is true. Now we need a way to toggle the value of the user dropdown open data property. We'll add a click event listener to the router link where our user name is displayed. And then we'll change the router link tag to an A tag instead, since we no longer want clicking on the user's name to take us to the profile page, but rather to toggle the dropdown. And we'll clean it up by removing the to attribute and adding a .prevent to the click event so that the browser will not try to follow the link. Since the user name itself no longer links to the profile, let's reinstate the router link, this time around the View Profile item in the dropdown. Back in the browser, we can now open and close our dropdown. Sweet! Class binding is a powerful tool, as demonstrated here. You'll find yourself using it all the time. In the next lesson, we will implement authentication via third-party providers. Now that we've taken care of the user authentication, we can easily implement any of the third-party authentication providers that Firebase supports. I really love how powerful and convenient Firebase authentication is. The first thing to do when using any provider for authentication in Firebase is to enable it in the dashboard. We will be using the Google provider, so I will enable this one. Now, we can use the Firebase sign in with pop-up method to either create users or sign them in. I will create an action, sign in with Google, to get this started. First, we need to instantiate the auth provider that we want to use. In our case, the Google provider. Then, we can sign users in, either by redirecting the users to Google or using a pop-up. We will go with the latter, so we will use the sign in with pop-up function. Here, we need to pass the provider we want to use. If the authentication succeeds, we can access the authenticated user under the response. So, at this point, we know that we have an authenticated user, but we don't know if they exist in our database or not, because remember that we will call this action either when users sign in or when they register. Thus, we need to check our database to see if there is a user with the ID equal to the authenticated user's ID. The returned document object provides a property called exists. So, if the user registered just now, user.exists will be false. Thus, here we should store the user in our database. We can find the user info under the user object. though the user object doesn't have a username, but we can use the user's email for that. Later, the user will be able to update the username in the profile page. Let's try to create the user. I will add a method to the register page component. And trigger it when the Sign Up with Google button is pressed. Now, over in the browser, I can register a new user with my Google account. Awesome. Let's also implement signing in with Google. I will create a method in the sign in page and call our sign in with Google action. Then we will call this method when the sign in with Google button is clicked, and we are good to go. I will log out, press sign in, and sign in with Google. Ta da! I'm signed in with my Google account. Unlike all of the other data fetched from the Firestore in the created or mounted hooks of the visited pages, the data for the user is fetched in the auth state changed event provided by the Firebase authentication service. Because of that, we don't necessarily want its snapshot unsubscribed from on route change, like all the other data snapshots. In fact, because the snapshot is created in the auth state change event, but then unsubscribed from when a route in our app changes without ever being recreated, that means we'll never receive any real time updates to the authenticated user. You can see this issue in action if you create a new post. You'll notice the user's posts count does not increase. So, for the auth user, we only want to unsubscribe from the snapshot only when the auth state changed event has fired. That would make it so that once the user logs out, or if they log in to a different account, the browser would no longer receive snapshot updates about the previously logged in user. In order to accomplish this, the first thing we want to do is provide a place to store the unsubscribed function for the auth user snapshot. We'll create a property in the state called auth user unsubscribe. Then, we'll create a mutation in order to set that state. Next comes the tricky part. The fetch auth user action calls the fetch item action, just like all the other fetch resource actions. And the fetch item action automatically appends the snapshot unsubscribe function to be called on route change. So, how might we provide a different behavior just for the fetch auth user action? We could create a condition inside the fetch item action that checks to see if the resource specified is a user's resource. But this would apply to any user and thus would not function correctly. So maybe we add an additional check to see if the ID passed to the fetch item action is the auth ID. This would probably work fine, but I don't like how our generic fetch item function is now polluted with logic about a particular resource. Instead, let's put the responsibility of committing the set auth user unsubscribe mutation on the fetch auth user action, where it belongs. We can do that by making the fetch item action accept a callback function to handle the unsubscribe. And we'll make it optional. If it's not provided, we can continue to commit the append unsubscribe as we did before. Then, in the fetch auth users action, we will provide the callback, which will commit the mutation. And we need to make sure to pass the unsubscribe to the handle unsubscribe function. Now that we have the unsubscribe function stored for the auth user snapshot, all that's left to do is to call it at the appropriate time when the auth state changes. We'll create another action to do that. I'll do it here under the unsubscribe all snapshots, just because it's related. I'll also check to make sure the auth user unsubscribe is set before we try calling it. Finally, I'll reset the auth user unsubscribe to null after it's been called. And then we can call it over in the on off state changed callback. Great, that should do it. Let's throw a console log in the on snapshot event in fetch item and make sure things are working as expected under the hood. Now we can log out and back in again. Let's open the console and clear it out so we can see a little bit better. And when we create a new post, it increments the post count correctly. And in the console, we see the console log for our user snapshot. If we make an update directly in the Firebase console, we'll see the console log again. But if we log out first and then do the update in the Firebase console again, the console log never happens. Perfect. Lastly, we'll remove that console log. And that wraps up the chapter on user authentication. The Firebase Authentication Service provides a straightforward way to manage users, as well as many third party providers, out of the box. After implementing authentication, a common need is to protect specific routes from guests. For example, a guest shouldn't be able to visit the user profile page. In View Router, to protect a route, we use navigation guards. Navigation guards can be global, as we define the before each guard in app.view to hide the contents of the page and start the progress bar. Navigation guards can also be defined in component or per route. In these lessons, we will learn about the navigation guards before we integrate them with Firebase. Let's begin with the in-component navigation guards. These guards work like the lifecycle hooks and come in handy when you need to access components data from within the guard. Let's see how we can use them in the profile page component. The available component guards are the before route enter guard, the before route update guard, and before route leave. Navigation guards always accept two arguments. The to argument, which is the route that is being navigated to, and the from argument, which is the route that is being navigated away from. It's easy to guess when the before route enter and before route leave guards run. The before route update is special though. It triggers when we are navigating from a route to another where both render the same component. This happens, for example, when we are navigating from a thread to another thread, since both routes render the thread show component. To protect the profile page from guests, we could use the before route enter guard and redirect the users to the home page if they are not authenticated. To do that, in here we can check if we have an authenticated user in the state. And if we don't, we'll redirect to the home route by returning the route named home from the route guard. Okay, the logic here is sound. However, in the before route enter guard, we don't have access to the component instance as the component has not yet been created. So this .store will be undefined. To solve this, we can import the store. By doing this, we are importing the current store and not a new instance, so we can safely use it here or in any other file. Also, for now, I will comment out the contents of the profile page and display a heading instead to make our lives a little bit easier, since we haven't revived the profile page since implementing the Firestore. I'll also comment out the import and registration of these components, as ESLint will complain now that they are no longer being used in the template. Since the auth ID is initially set to null, when we try to visit /me, we should be redirected to the home page. And we are. Awesome. To test that it works properly for users, I will manually set the auth ID to something. In just a few lessons, we will make this work with the authenticated user from the Firebase authentication service. But because of the async nature of that, it becomes a little bit trickier, so I'll just hardcode it for now. Lastly, I will omit the ready event from the profile page. This time, we should see our heading when we visit the profile page. Great. Before we move on to the per route guards, I want to show you a common use case for before route leave. When creating a thread, if the user has written something in the form and clicks a link, then all those changes are lost. To prevent that, we can ask the user to confirm the navigation before leaving the page. To do that, we can use the before route leave guard in the thread create page to show the confirmation. If the user confirms it, we will perform the navigation. Otherwise, we will abort it. To abort a navigation, we return false from the guard. Let's check it out in the browser. I will click Cancel, and we get the confirmation message. If we cancel the confirmation, we stay here. And if we confirm it, we are free to leave. That's nice. Though I find it frustrating to have to confirm the navigation when I haven't typed anything. To improve the user experience, we should check to see if the form has any changes made to it. In order to do that, we can add a watcher in the thread editor to keep an eye on the form data to see if it's changed from what it was initially. We do this by adding a watch property to the component options. And then we add a method named after the data that we want to watch. In this case, the form. And, actually, in our case, we need to define the form watcher as a property instead of a method. That way we can pass the deep option. The handler function here does the same thing the method we wrote just a second ago would have done. It's the function that runs whenever a change to the form data property is detected. The deep option here tells Vue that the method should run not just when a change occurs directly to the form data property, but also to any of its properties, that is, form.title and form.text. Inside the handler, I'll check if form.text and form.title are anything other than the originally passed title and text props. And if they are different, I'll emit an event called dirty. This is a common term used to indicate that a form has unsaved changes. In other words, a dirty form is a form with unsaved changes. I'll also add an else statement here to emit a clean event. Though this might be unnecessary for most situations, it does make it so if the user makes a change to, let's say, the title, but then backspaces those changes so the title is back to what it was originally, then the form will be considered clean again. Now, let's listen for those events in the thread create page and update a data property accordingly. And we'll need to actually create the data. I'll initialize it to false, as the form won't be dirty by default. Now, we can only show the confirm message before route leave if the form is dirty. This should do the trick. I will log in and create a new thread. If I click Cancel Now, after typing in some data, I get the confirmation window. But if I backspace things to the way they were originally and click Cancel, I don't get the confirmation window. Also, if I go directly to start a thread and then navigate away, I also don't get the confirmation window. This is nice. There's still one problem though. When I hit Publish, I still get the confirmation pop-up. This is because, in the save method, we redirect the users to view the thread they just created. To fix that, I'll just omit the clean event from the thread editor save method, since, on save, the form should no longer ever be considered dirty. Back in the browser, I still get to confirm that I want to leave the page while I have unsaved changes. But this time, when I hit publish, the thread is created and I'm redirected to the thread page. As an exercise, you can implement the same feature for the thread edit page, since we've given the thread editor the responsibility of knowing when things are clean and dirty. It should be fairly straightforward. If you get stuck though, feel free to take a look at the solution in the source code of the video. In the next lesson, we will learn about per route navigation guards. In-component guards are very handy when we need to redirect or cancel a navigation based on the component's data or a child component's data. However, there is another way to define before enter guards, that is, by registering them per route. We can do that in the router file. Sometimes this is also known as middleware. To get started, I will implement the guard that we implemented in the previous lesson to protect the profile route from guests. I will cut the code from the profile page component. And while I'm here, I'll clean up these unused guards. Then I'll paste the code over in our routes file. I'll change the name of the function from before route enter to before enter. This makes sense, as the function is now defined on a route, and so the route part is inferred. And since we've already imported the store into the router file, we are good to go. Also, since the profile component doesn't need the store variable anymore, I'll remove the import statement. Now, if we change the auth ID back to null, and try to visit the profile page as a guest in the browser. We are redirected back to the home page. Cool. I'll just change the auth ID back. To me, it makes better sense to have auth related guards in the router file so they are organized, and you don't have to open the component to see if it's protected or not. Even better, you can define auth related guards using metafields that we'll talk about in the next lesson. My favorite use case for per route guards is what I call componentless routes. These are routes that don't use a component. Let me show you. At this point, we don't have a route to log out. So, in order to sign a user out, we dispatch the sign out action from the navbar. This is fine, but it'd be nice to have a route, like /logout, that will dispatch our action and redirect the user somewhere like the home page. Normally, to implement that, we would create a page component with an empty template, and we would do the job in the lifecycle hooks. Using per route guards, we don't need to do all of these things. Let's get to it. I will create a new route with a path of logout. I will give it a name of sign out to comply with the other route names. Then, using the before enter guard, I will dispatch the sign out action and redirect the user to the home page. Also, to make sure the sign out action is complete before redirecting, I will use async await to wait for the action to be finished. And that's it. Notice that we didn't have to specify a component here. Let's give it a shot in the browser. I will sign in, and then, instead of clicking the sign out button, I will visit /logout. And, as expected, I am signed out and redirected to the home page. Great. In the next lesson, we will dive into the global navigation guards and metafields. On top of defining navigation guards in components and per route, we can define global navigation guards. We can register global before guards using routers before each method. In fact, we've already defined the before each global navigation guard in order to clean up our snapshots. Just like all the other navigation guards, we see that before each takes a callback function. In this case, that callback function will run before every route is visited. As you might expect, the callback function can also take the to and from arguments. Just to make what's happening more visible, I'll add a console login here so that we can see each navigation. Now, in the browser, we see each navigation in the console. So, if you need to run some code before each navigation, this is the way to go. Since we have already used the global navigation guard to unsubscribe from all our snapshots, let's go a step further and introduce metafields. Route metafields let us add custom attributes to the routes. Using the meta, we store arbitrary information about the route, and then take some action based on that information. Let me show you. I will add a meta attribute to the profile route, and I will call it requires auth. I will give it a value of true. It's worth noting the name of the property here is completely up to you. It could be requires auth, protected, skinny jeans, literally anything you want. I just chose requires auth as it makes the most sense for our use case. Not only that, but the metadata can pertain to any type of data. It's not just for indicating that a page requires authentication. Maybe it has a piece of meta that describes the type of transition that should be used on a page. Or maybe it indicates that the page should smooth scroll on navigation, or navigate to the top, as we've already done in a previous lesson. I'll just remove this transition as it's not needed. Once we set the meta to the routes, we can check inside the global navigation guard if the route we are navigating to has a specific meta and act based on that. In our case, we can check to see if the route has the requires auth meta and make sure that the user is authenticated before we let him visit this page. In other words, we'll do exactly what we've done here in the before enter guard. I'll cut the before enter guard method here so that we can use it in our global navigation guard below. So, if the requires auth meta exists, we do what we were doing on the navigation route level guard a minute ago. I'll clean this up. Let's see if this worked. Let's make sure that the auth ID is set to null real quick. And check back in the browser. And yeah, we still get redirected to the home page. Great. You may think, what have we actually accomplished here? We have just moved the route guard around. However, now in order to protect another route, all we have to do is to add the corresponding meta instead of having to rewrite the route guard. If I add the meta to the category page, for example, we wouldn't be able to view it without logging in. It's hard to see it since we're already on the home page, but I'm getting redirected right back home. Let's just remove that, as it was only an example. Meta is also inherited by child routes. So, if the profile route had a child route called nested, let's say, it would also require that the user be logged in. In View 2, making this work would take a little extra effort, but in View 3, with ViewRouter 4, this is handled for us since the meta is a non-recursive merge of the child and parent meta. I'll demonstrate this by visiting /me/nested in the browser, and we're redirected back to the home page. Nice. Let's remove the nested route since we don't need it. In the next lesson, we will integrate our authentication system with the navigation guards and stop having to fiddle with the hard-coded auth ID in the store. While we have managed to apply a navigation guard and protect specific routes from guests, we haven't yet been able to integrate Firebase authentication with our route guards. The reason for that is that in our route guard, we need to check if there is an auth ID in the state. The thing here is that the auth ID is updated asynchronously. Specifically, the auth ID is initialized to null, and our Firebase observer updates it when the auth state changes. Thus, we need somehow to wait for the observer to trigger in order for us to know if a user is authenticated. If the authentication was initialized through an AJAX call, we would perform the call here by most likely dispatching an action. And then we would proceed with the navigation when the promise was resolved. Like this, we need to implement a way to know when the Firebase State Observer has been triggered, and then proceed with the navigation. Let's take a look at our observer. The callback will run whether there's an authenticated user or not. So, if we wrap this in a promise, we can resolve it when the callback runs for the first time. To get started, I will create an action, init authentication, and I will place our observer inside. We'll also need to replace the instances of the store variable with this. Now, if we return a promise from our action, we can resolve the user coming from Firebase. Notice here that even though we resolve the promise, the observer will continue to run in the background unless we turn it off. I will add a console log to know when the callback runs. Now, let's dispatch the init authentication action inside of our global navigation guard, waiting for it to complete before doing anything else. And I'll just make sure our main.js file is saved. Okay, let's check it out in the browser. When we visit the home page, it works. And we see the console log. Now, let's try to log in and visit the profile page. This works as expected. While this approach seems to be fine, there is a significant issue. I will sign out to show you. Notice now that our console log is printed out 4 times, one for each page we visited. This means that every time we visit a page, we create a new observer. To solve that, we need to turn off the current observer before we create a new one. There is one way to turn off the auth state observer, and this is by using the unsubscribe function that is returned when we initialize the observer. This behaves much like the unsubscribe from onSnapshot functions that we've already seen. Once we get the unsubscribe, all we have to do is to call the function, and the observer will go off. So, we can store this function in the state and call it before setting up a new observer. For that, I will add an auth observer unsubscribe state property. And create a mutation to set it. Now, we can set the unsubscribe function to the state right after initializing our observer. Now, Before we set up the observer, we can check if there is an observer already listening, and if so, we will unsubscribe from it. If we check it out in the browser again, our route guard still works as expected. And this time, there is only one observer listening. We can confirm that by checking the console messages when the user changes. In other words, when we sign in or out. Great, now it only logs once. Let's make one small improvement before we jump into the next lesson. In the init authentication action, we resolve the promise immediately when the auth state changes. This is not wrong, but it's a good practice to wait for the authenticated user to be fetched from our database before we resolve the navigation, so that we know that we always have the user in the page components. So, I'll make our callback async and await for the fetch auth user action to finish. And only after that, resolve the user. Otherwise, we'll just resolve null. And actually, I noticed a flaw in our fetch auth user action. Here, we should make the action async so that it returns a promise. And then await for fetch item to finish. Now, we can be sure that before showing the page, the full user info is available. Though we've nailed down some great functionality in this lesson, I know it was a lot to follow. If you have any questions, feel free to leave questions or comments in the comments section below. In the last lesson, we saw how we can wait for async data to resolve in the global before each navigation guard. This is not limited to the global navigation guard, however. It can be done in any type of navigation guard. And it turns out this is the perfect solution for the before enter route guard we have commented out on the thread show route. The purpose of this route guard was to check if a thread existed or not before showing the thread show page, and if it didn't, redirecting to the 404 page. However, since we're not loading the thread from the Firestore until the page component is created, this was no longer working. So, all we should have to do now is uncomment the route guard, make it async, and fetch the thread from the Firestore before continuing on with the logic that was there previously. We'll also need to switch out the source data here for the store's state. Nice. Let's see what that looks like. Okay, it's still broken. I'll show you what's going on here. Let's console log what thread exists is returning. We're getting back an object with the ID of not exist. So what this is telling me is that there's an issue with the fetch item action. It is resolving with an object that is not the thread when the thread doesn't exist. We've yet to attempt to fetch an item that didn't exist yet though, so we haven't caught this up until this point. Let's fix that. In the fetch item action, we can use the special .exist property on the Firestore document to see if the returned object actually exists or not. If it does, then we'll proceed just as we have been. Otherwise, we'll resolve null, as in the document was not found, so it's null. Now, back in the browser, our not found page is back in service. Awesome. Let's remove our console log. And while we're at it, we can clean up the last remnant of our static data in the import at the top of the routes file. Now that we've completed our route guards, or middleware, let's finalize which routes should be protected. To begin with, we want to hide the profile settings page from guests. So, I will simply append the requires auth meta field to the profile edit route. Next, we can prevent guests from creating and editing threads. Thus, let's append our meta to the thread create and thread edit routes. While this prevents guests from accessing the thread create and thread edit pages, it's all client side. There is nothing really stopping the request from being made directly to the Firestore database for creating or editing a thread. For example, if you open up the app JavaScript bundle and look through it, you can find the Firestore API key, the auth domain, and everything else you need to make requests directly to our Firestore instance. Anyone could come in here and copy the values and use them, just like we do in our project. Thus, we need to set up some rules on the server side, that is, in the Firestore itself, to decide whether or not someone has access to modify a thread or post. While we won't dive too deeply into the Firestore rules, let's just quickly take a look at the basics of how we might secure the threads and posts on the server side. Firestore has some great documentation to help us out with this. I'll leave a link in the description below to these docs so that you can dive in deep yourself if you want to. If we visit the Firestore database in the Firebase console, you'll see this link called Rules. The only rule that we have registered right now is the one that Firebase set up for us when we created the database. It's essentially a development free pass that says you can read and write to the database any way you want to until this date. Let's add a rule targeting how the threads can be read and written. You can target a collection using the match keyword and using this file structure like syntax. The word thread here in curly braces is like a variable that says do these rules when trying to access any thread document inside the threads collection. Next, we can specify what we want to allow and on what condition. I'll start with reading. Since everyone can read our threads, our condition here is easy. It's just always true. Cool. Well, what about writing? This is where the functions are a little bit more important. Let's code that out a little bit with some imaginary functions. First, any logged in user should be able to create a new thread. We can write that something like this. If the user is logged in and the thread is new, then allow writing. The other scenario where a user should be able to write a thread is when they are editing their own threads. We could probably also enable moderators to edit threads, but we won't worry about that right now. So, the condition now looks something like this: allow write if the user is logged in and is creating a new thread, or if the thread they are wanting to write to belongs to them. Nice. So what's cool about this is that Firestore actually supports defining functions inside of our rules, so we can actually make these functions work. We can do this just above the allow rules using the function keyword. In order to tell if the user is logged in, Firebase exposes a request object to all of our rules. Also, if the user is logged in, the request object will have an auth property that will contain the user from the Firebase authentication service. So, we can write our function like this. Next, let's work out the isNewThread function. Besides the request object, Firebase also exposes a resource object. This variable refers to the document you are attempting to write to. In the case that the document doesn't already exist, the resource will be null. So, we can write our function like this. Now that we're aware of both the resource and request variables, our last function is fairly straightforward. We can check for the ID of the authenticated user on request.auth.uid and compare it to the user ID on the thread. In order to get to the data on the thread, you must look under the nested.data property. Nice. That takes care of threads. But if you remember, creating a new thread actually also creates a new post. That is the first post in the thread. So, let's make the same rules for posts. And, instead of duplicating the functions, we can dry up our code by making the function names more generic and pulling them up above both matches. Nice. That's cleaner. Now, we need to alter the rule that Firebase gave us by default to only allow reading of everything and not writing. This is because rules in Firebase look for any passing rule. So even if our thread and post-specific rules prevented writing to a particular resource, this more generic rule would allow it. We'll also remove the time frame now and just always allow reading of all the data. This also means that we can remove the individual reads from the posts and threads. There's also one more thing we need to account for when creating new threads and posts. Creating a new post appends a post ID to its parent thread and the user ID as a contributor. Also, creating a thread appends the thread ID to its parent forum. This is getting a little too deep into the woods of Firestore, so I won't explain in depth. But essentially, we need to allow users to update only the posts and contributors properties of a thread that isn't theirs. And a user should only be able to append a thread ID to a form's thread property. While these two rules prevent an unauthorized user from setting any field other than posts and contributors on the thread, or any other field than threads on the forum, the rules do not prevent any user from setting invalid data to either of these. For instance, a malicious user could push a post ID to a thread that the post doesn't actually belong to and make it look like a user commented on a thread that he or she never did. However, I don't want to dwell on these rules for too long, so this will suffice for now. Perhaps with the Firestore rules documentation in hand, you can figure out a good solution for this yourself. Also, remember that these rules depend on the business logic and what permission you or the product team decide to allow users to have, and what actions should be allowed. With the rule definitions we've covered in this lesson, and the guidance of the Firestore documentation, you can define any business logic you need for your own applications. Finally, while we're here, we'll make it so that anybody can register as a new user. But an existing user can only update themselves. Sweet, that should do it for securing our database on the server side. While we're allowing reading of everything, there is nothing in the database that isn't public already. Any of the user's private data is in the auth service itself. Should you want to store any private data in the Firestore, in the future you definitely have to adjust these rules. Let's copy and paste the rules from the console and save them into our Firestore rules file so that we can keep track of them in version control, and so they're accurate if we ever run Firebase deploy in the future. Awesome. Now let's try it out in the browser. In order to show that attempting to create a thread as a guest user doesn't stick, I'll comment out our route meta. Then I'll make sure I'm logged out and try to create a new thread as a guest. When I do, you see I get this Firebase error in the console. And if I go back to the forum, the thread doesn't exist. Perfect. Now, if I reinstate the route meta, I can't get to the thread create page at all. Let's also log in and try to edit a thread that's not our own, just to show those Firestore rules working. While the user experience here isn't necessarily great, our rules are working and we can improve the user experience later. Let's summarize what we've learned in this lesson. Route guards are great for preventing user access to certain pages in single page applications. But we must remember that the route guards all happen on the client side. They primarily exist for user experience. We must still protect our data on the server side, in our case with the Firestore rules. In the next lesson, we'll protect some pages from logged in users for the sake of user experience. In the last lesson, we took steps to hide pages that only logged in users should see from guests. Another thing we should consider is hiding some pages from authenticated users that don't make sense for them to see. For instance, users shouldn't be able to visit the login and the register pages. I will add a new meta field to these routes that I will call requires guest. Let's implement this requires guest middleware. Inside the global navigation guard, I will add a new check for the requires guest meta. In this case, if there is a user, we will redirect the user to the home page. Also, since we are here, I want to make the requires auth middleware redirect to the sign-in page instead of the home page, since really that makes more sense. Cool. I think we're good to go. Let's test out all our middleware in the browser. I am a guest, and I will try to create a thread. As expected, I am redirected to the sign-in page. Let's try to edit a thread. Just so you know, later on, we will hide the Create Edit Thread buttons from users that are not allowed to perform these actions, because the flow right now is a little weird. Next up, I will sign in and I will try to create a thread. Nice, it works as expected. I'll edit the thread. Cool, also works. And let's try to visit the sign in page. Nice, I'm redirected to the home page. The same happens when I try to visit register. In the next lesson, we will improve the user experience regarding the redirects. I can't stand it on a website when I'm required to log in to proceed, but then I'm redirected to a random page, like the home page. What I expect to happen is, for example, when I click Start a Thread, to be redirected to the Create Thread page after logging in. We have a few different options on how to implement that. In our middleware, we can pass the route the guest is trying to visit to the sign-in component as a prop. I want to show you another way though, and this is to use a route's query parameters. Query parameters are the text you see in the URL specified after the question mark. For example, in question mark day equals Monday, the query param is the day and the value is Monday. If there are multiple query params, they are separated with an ampersand. In the middleware, where we specify the sign-in route, we can append query parameters using the query property. So, in order for the sign-in component to know where to redirect to after the user is logged in, we can set a query parameter, let's say redirect to the path the user tried to visit, which we have in the to argument. Let me show you how this looks in the browser. If I go to a forum as a guest and click Start a Thread, you can see that I'm redirected to the sign-in page, and the query parameter redirect to is set to the thread create path. Okay, this is cool. Let's tell the sign-in component to use the query parameter. I will create a method called success redirect. Here, I will create a variable redirect to that will have the value of the query parameter, which we can access under this.$route.query, and then the name of the parameter. Be careful here not to confuse the $route with $router. The $route is the active route, while the $router is the global router instance. If the query param is not defined, I will set the value of redirect to a default path, which will be the home page. Next, all we have to do is to redirect to the desired path using router.push. Cool. Now I will replace the lines where we used to send the users to the home page with a call to our new method. That's in Sign In with Google, and here in our regular sign in method. Okay, let's give it a shot in the browser. I will try to create a thread as a guest. I will log in, and this time I am redirected back to where I wanted to be. Awesome. If I log out and visit the sign in page, when I sign in, I'm redirected to the home page since the query param is not set. This feature is not something huge, but I believe it's a great improvement to the user experience. In the next lesson, we will improve the user experience for the post-related actions from guests to work better for the Firestore rules we made earlier. In the previous lessons, we protected the thread create and edit pages from guests, though we still show the thread edit button and the post editor inside the threads. Even though the Firestore rules don't allow guests to do either. So, in the thread page, we can use the auth user getter and conditionally render the post editor. If the user is not authenticated, we can display a helpful message, intriguing the user to either sign in or register in order to post a reply. Here, we can also pass the redirect to query parameter to help the user find the thread after logging in. We can access the active path under $route.path. And I'll do the same for register. Let's give it a shot in the browser. While I'm logged out, I see our message. And if I sign in, I'm redirected back to the thread, and everything works like it did before. Cool. While we're here, let's also hide the Edit Thread button for users who didn't create the thread. I used optional chaining here for when the auth user is null in order to quickly handle guests. Let's see what this looks like. When I visit a thread that's not mine, I don't see the button. But when I visit my own thread, the button is visible. If I log out, the button disappears in front of our very eyes. Very nice. In the next lesson, we will fix the authenticated user's profile page. A few lessons ago, we commented out the contents of the profile page so that we can more easily work with the navigation guards. I will revert that now and get our profile page working again, since we've left it broken since moving our data to the Firestore. To begin with, let's see what we get in the browser. The page works, since the authenticated user is fetched in the navigation guard before the page is rendered. That's good, but we don't see any posts or threads, and the sidebar here on the left is a little narrow and funky looking. Not sure what's happened there, but we can fix it real quick. Nice, that's much better. Now, the more important issue, why don't we see posts or threads? Hmm, oh, of course we don't, since our Vuex store is empty. So, let's review what our component needs. The post list component is passed user.posts, and user.posts is a getter that looks for all the posts in the state with a matching user ID. Other than that, we don't need any more data to get the posts working. Okay, so what we have to do is to fetch the user's posts before we emit the ready event. However, we can't use the fetch posts action as it expects a list of post IDs to fetch. And we aren't storing the post IDs on the user, but only the user ID on the posts. Thus, we need to be able to query the post collection for all the posts where the user ID matches the current user ID. We can do that by targeting the post's Firestore collection and adding a where clause. Let's create an action that does this. I'll call it fetch auth users posts. Then I'll target the posts collection and call .where. Where takes three arguments. The first is the field you want to make your comparison to. We want to use user ID. The second is an operator. Should the field equal some value, be greater than some value, not equal some value, and so on? We'll say that it should be equal to the third argument. And the third argument is the auth ID. Now, we'll call the get method to execute the query. Unlike the Firestore onSnapshot method, get only executes once and does not listen for updates, but that's fine for our current use case. That also means we don't have to do any unsubscribing to the snapshot events. Now we can await for the results and loop over each of them to set them to the state. Sweet, that should do it. Let's go dispatch it in the profile page's created hook and wait for it to finish before emitting ready. Let's see if that did the trick. Nice. Now we have the user's posts. Even though we emit the ready event directly when there is no asynchronous calls in the created hook of a page component, we have created a mixin that handles that for components that need asynchronous data, like our profile page does now. So let's import and use our mixin. Now, in the created hook, we can call the fetched method when all the calls are done. Yep, still good to go. In the next lesson, we will work on the edit profile page and learn a cool router trick. In this lesson, our task is to fix the profile edit page. If we try to do that, we will face an issue that I'd like to explain first. The created hook triggers when a component is created, right? But when is a component created? When we visit the thread page, for example, the thread show page component is created. But what happens if we navigate to another thread directly? Since there is no way to navigate to another thread, I will add a link to a random thread on top to show you. And I will add a console log in the components created hook. When I visit a thread, we can see the message in the console. Now, if I click the link for the random thread, I am redirected to the thread, and besides the page not working, the created message doesn't appear in the console. This is because the thread show component is created the first time we visit the thread. And when I click the link, View Router switches the props and the URL, but the component is not remade from scratch. Because of this, the created hook is not run again, and thus the application breaks because we rely on the created hook to fetch the necessary data. To force View Router to destroy the page component when we navigate away, and thus create a new instance on every page view, there is a neat trick. We can pass a key to the router view component that will always be unique. This unique key can be the path of the active route. The router view component renders the matched component for the given path. So in our example, router view will be the thread show component. By passing this unique key, we force View to destroy the current component and render a new instance every time the path changes. This is the default behavior when navigating to a route that uses a different component. So, by passing a key, we actually apply the same behavior to routes that use the same component. If we try the same steps again, this time the second thread works fine, and we also get to see that the component is created in the console. Make sure you refresh the page before you try this, since if you've visited the thread page once, the thread has already been fetched and stored in Vuex, so the second page might work just fine because it already has the data. I will clean up the thread show page component before we start with the edit profile page. Since we have added the key to the router view, we can now navigate to our profile and then edit it without any issues. If we hadn't have added the key, we would have faced a bug since both routes use the page profile component. If we try to make updates to the form, however, our changes don't stick. This is because we haven't saved the user data to the Firestore. Let's update the update user action to save the data to the Firestore. Here, we receive an object, which is the whole user object. It includes all the attributes, like posts and threads, that shouldn't be editable directly. So, I will create a new object with the data that we want to let the users update. And because Firestore doesn't like undefined values, and some of these could possibly be undefined, let's make each one null if not provided. Next, we'll get the Firestore document ref. And this time, since we're only updating one document, we don't have to create a batch. Instead, we just call update directly on the ref and pass it the values that we want to update. That should do it. Let's check it out in the browser. Whoops, we forgot to make our action asynchronous. All right, I'll make an update, and we see that it's stuck. When I refresh the page, it's still there. Great, our data is persisting. In the next lesson, we will modularize the store since it has started to get a little hard to maintain.